Hello, this is Dr. Eddie Morgan at Clovis East High School. I'd like to help you with your homework tonight. We're looking at the Math 1 assignment, worksheet 2.1a. Remember, each of these problems is very similar to the problem with your homework. If you're looking at problem 3 in your homework, look at problem 3 here and you'll see a very similar problem. As you look at the homework help, you should be able to figure out how to do the problem on your homework. So let's get started. The first problem says, what are the variables in the graph at the right? Use the graph to describe how the variables are related. Well, to find the variables on a graph, it's easy because you just have to look at the two labels. You see we have the time and we have the height. So if I was writing down my variables, I would write time and height. Now we don't have enough information to say exactly what this graph is, but this, for example, might be the graph of a ball falling off a building, for example. It starts here, and the longer the time is, the height goes down and down and down. Or perhaps you were simply, you're at the top of a building and you drop something, and you notice as you drop it, as time goes this way, the height gets lower and lower and lower and lower and lower. So as time increases, height decreases. So the relationship I might say here would be as time increases, which means, as I said here, it's going to the right, height decreases. And you see, as time decreases, is going that way, height is going down. Problem number 2 asks us to describe the relationship between time and temperature in the table at right. Notice the time is measured in the number of hours after dinner. So this starts at like 6 p.m. is when we have dinner. That would make this one 6 hours later would be 12 a.m. or midnight. 6 hours later would be 6 a.m. in the morning. And then from 6 a.m. that many hours later is going to be noon. And then we'll be back to dinner time the next day. So we're really looking at the temperature as it goes from dinner one night to dinner the next. Now you notice from midnight to the morning, it goes down slightly. So from midnight, it's at 62. It drops down 4 degrees to 58. From 6 o'clock in the morning to noon, it goes up, but just 2 degrees, 58 to 60. And then we have a large increase from noon to dinner time. So if you're having to write this out, I would say, as time increases, the temperature decreases slightly from midnight to morning. Then it increases slightly from morning to noon. Finally, it increases more rapidly from noon to dinner time. That would be our description. Problem 3 asks us to match one of the labeled segments in the graph at the right with each of the following verbal descriptions. First of all, let's consider these. Rising slowly would mean that it's going up but slowly. This would be rising rapidly, but this would be rising slowly. So for rising slowly, we're probably looking at D. So rising slowly, so D would be rising slowly. The next one we're looking at is constant. Well, constant means it just stays the same. So as we look here, A is going down, B is going down, C, D, we're looking at E. Notice that stays the same. So E would be our constant. And lastly, falling quickly. Well, falling slowly would be like this, but falling quickly would look like this. So you see both A and B are falling, but A is the one that's falling quickly. Just notice the difference between, again, rising quickly or rising slowly, falling quickly or falling slowly. Problem 4 is an error analysis. It says that t-shirts cost $9.99 each for the first 5 shirts. So the first 5 shirts are going to cost this amount. Then every additional shirt costs $3.99. So the price goes down after you've bought 5 shirts. Describe and correct the error in the graph at right that represents the relationship between the total cost and the number of shirts purchased. Well, the thing to notice is here's the number of shirts and here's the total cost. Notice that when I buy 1 shirt, there's the cost. But notice that when I buy the second shirt, the cost hasn't changed at all. Instead, if we look here, it looks like 1, 2, 3, 4, 5 shirts are all, the price doesn't go up at all. In other words, what's happening here is they're not measuring total cost, they're actually graphing the cost of 1 shirt. And so when you buy the first one, it's $9.99, the second one is $9.99, each of these until you get to 5, and then it drops down to a lower price. So this isn't measuring total cost, it's measuring the cost of 1 shirt. If we wanted to measure total cost, and so we need to put our own graph here, we're going to put number of shirts down here, we need to label it. And the other side here is our total cost. When I buy 1 shirt, it's going to cost me $9.99. 2 shirts, $9.99. Another one, but now my total cost has gone up. 3, 4, 5. But once I get past 5, now instead of going up this amount, it's going to go up a smaller amount. Okay? So I end up with a graph that looks something like this. It goes up steep for the first 5, and then it goes up that way. In other words, it rises more rapidly at first, and then because the price goes down, the slope of the line decreases, and it's less for the rest of the graph. Problem 5 is about a hot air balloon. Sketch the graph of each situation. Are the graphs the same? Explain. The first part asks me to graph what's my height as my hot air balloon is tethered and filling with air. Well, if it's tethered and filling with air, then what's happening is I'm just sitting on the ground right here, okay? And it's tethered, so what does my graph look like? Well, let's put time, and let's put height. Well, let's just say I'm, you know, they've got it off the ground a little bit, but during this time, I'm tethered, it's filling with air, but I'm not going anyplace, so during this time, my height just stays the same. Whatever the height is, it's very small. I'm on the ground, I'm tethered, so, you know, maybe they've got the ropes, you know, maybe they've got the ropes down the ground here so that I'm, you know, I'm a little bit off the ground, but I'm not going anyplace because I'm tethered. On the other hand, in number B, the height of your balloon as it ascends to 5,000 feet. So I'm going to go up to 5,000 feet, and then I'm going to float at that height. So once I get there, I'm going to stay at a certain height, and then I'm going to go to a ground. Okay? But how does that look on a graph with time? With time, you can see same graph. I start here where I'm tethered, and I ascend. I don't just go immediately there. It takes me some time to go up to 5,000 feet. At that point, I'm going to stay at that height for a while. So we float for a while at that height until we figure it's time to come back, and then it says we descend. Again, we just don't drop down, but we gradually descend all the way to the ground, and that would be our graph. Obviously, these graphs are not the same. This one is constant because we're just tethered. This one, it shows the balloon rising over time, leveling off over time, and then descending. Problem 6 says, what are the variables in the graph at the right? Describe how the variables are related at various points on the graph. So as we look here, we have two variables. If I'm write down my variables here, I have time and I have distance from home. Those are my two variables. So you notice if we describe it, at first we're at home, okay? And then we begin to leave home, and so as we go away from home, we're gradually going away from home, and we reach a point where we reach someplace, and then notice we stay the same. So at this point we've gone here, we've stayed the same, and then we go on to someplace else and we stay there a little while, and then we finally come back home. So you could describe this in certain ways, to describe the relationship over time. As time goes by, we leave home and travel to our first destination. That's this line here. Once we get there, then we stay there for a while. And that's this part here. After that, we go to another destination, which is farther away from home. Travel there, and we stay there for a while. Finally, our last section here, we go back home. This could be a scenario, for example, we might drive to a restaurant and stay there and have lunch. And then before we go home, we go to the store and pick up some hardware or something, and then we drive back home. That's the kind of graph that's marking off. Problem 7 says that the table shows the amount of water in a tank based on the number of times you pour a bucket of water into it. Which graph could represent the data shown in the table? As you look at the table, first of all, notice before you put any water in it, there's a zero amount. And then when you bring one bucket, you put in 64 ounces. The second bucket is 128, so notice that it went up another 64. And then a third bucket is another 64. So each time it goes up by the same amount. So as we look at these graphs, a couple things to notice. First of all, when there's zero money. Notice in graph A, it doesn't start at 0, it starts at some value there. Likewise, C starts up here too. So these two would be wrong just because of where they started. B starts exactly at the origin, and then notice it goes up the same amount each time, and so this would be the graph that's more likely to describe, to represent the data shown in the table. Problem 8 asks us to sketch a graph to represent this situation in which what's the daily high temperature over the course of a year. So we're going to write our graph here. and we're going to put, I'm just going to put months of the year. So if we started at January, and then somewhere in here we would have April, we would have June, and we would have October, and then finally back to January. That's our months of the year going this way. Over here we're going to put the daily temperature. So this is our high temperature for the day. And how would we graph that? Let's suppose, if we were looking at Fresno, for example, what might be our high temperature in January? Well, our high temperature might be, let's say, in the, let's say this is 50, this is 25, 75. We've got to put some markers to make some sense here. Let's say we think the temperature is going to be about this much in January. Now, as the months go by, we expect it to increase. All right, it might waffle a little bit, but then into the temperatures here pretty slow, and then we start hitting June, and it starts getting up into the hundreds, and it might run 100 all that time, and then it starts coming back down to January. So we're basically showing the temperature in January slightly increasing, getting to summer when it gets really hot, and then decreasing back down by January of the next year. For our last problem, we're going to sketch a graph to represent what's the distance from the ground as you swing on a swing. So our two things are, once again, we're going to have time here, because as we swing, we're going to go up and down on the swing, and here's our distance from the ground. Notice that as you begin the swing, you're going to be pretty much on ground level. But as you swing, you're going to swing up in the air, you'll reach a certain height. Remember, time is going by this way, so it's going up, and you reach a point there where suddenly it comes back down. And then you swing back up, and then you swing back down. And so you see, as time goes by, that's going to be the kind of look of how high you are from the ground. You're close to the ground, you get as high as you can, and then you come back down almost touching the ground, and then back up, and as long as you swing, that's what your graph would look like. So that's the end. I hope you did well on this homework tonight.